MEDLI is a set of instrumentation that we're installing on the Mars Science Laboratory spacecraft. So we're going to take data during the entry of MSL through the Martian atmosphere.
The MEDLI data is really going to provide an order of magnitude more information than engineers have had in the past. We've never instrumented a Mars entry vehicle to this extent. We make a lot of assumptions in our simulations and our vehicle models. For instance, since MSL is so big, we expect the flow on the front of the vehicle during entry to transition to a turbulent state, which will raise the heating on the front of the vehicle. We're not sure where on the vehicle or when that will happen. We're also not sure how the vehicle's aerodynamic characteristics will change as the TPS material burns away. So these are all things that we can use our data for to improve our knowledge for the next lander. We also have a temperature subsystem, and that was developed at the Ames Research Center. And it's actually a plug of thermal protection system material that has contained in it 4 thermocouples at different depths in the heat shield, and also a recession sensor that sticks up to the surface and will tell us how much the heat shield will burn away as it flies through the atmosphere. This is an actual piece of simulated MSL aeroshell structure. The thermal protection system would be down here as the vehicle enters the atmosphere. And here is our pressure transducer connected via stainless steel tube through the structure, and then a hole that would extend through the thermal protection system where we would sense the pressure. Now, the Mars Science Laboratory has a heat shield that is the biggest one ever flown to Mars. And it's about 4.5 meters or about 15 feet in diameter. And across the vehicle we have 7 pressure transducers, and we also have 7 thermal plugs. And those were located very carefully by our scientists and principal investigators to look at some specific things. For the pressure system, the transducers are located in a cross configuration down the center line of the vehicle, and that allows us to then look at the different measurements and determine what the attitude of the vehicle was, the angle of attack, and also the angle of side slip. And this gives us an independent measure from the inertial measurement unit that's on the spacecraft. For the thermal plugs, the 7 thermal plugs, we've located those in areas where we expected the flow to transition from laminar to turbulent, so that we could predict where and when that transition would occur and where the heating might increase on the vehicle.
We're looking for additional information how the vehicle performs that we can use to apply to the design of the next generation of vehicles. And maybe will help define what the technology should be, as well as understand where the design assumptions that we've made for MSL are conservative or not conservative enough. So it will allow us to make designs that can land more safely or more cheaply on the surface of Mars in the future.